All right, everybody, we got to cover several things here, and some of this is going to be a review for you. And if you weren't here for the instructional part before Christmas, it actually may appear to be new, and that's okay. So, what we're going to do is we're going to review a couple of things: how to find zeros if you're given a zero or a factor. Then we're going to talk about how to write the simplest polynomial with given zeros. We're going to also review how to write the possible rational roots of a polynomial. And what I want you to remember is that as we go through this unit, and we're finishing a unit that we started before Christmas. So as we go through this unit, there are a couple of things you need to remember. Zeros have lots of different names, okay? When we're talking about equations, they can be called zeros, but they can also be called roots. So what I would encourage you to do right now, if you haven't already done it, is to get out a sheet of paper and to jot down some of these notes. Okay, and actually you may find your old notes from last semester, and this is, I believe, some of the same stuff that I did in a previous video, but I was just going to make a new one just to kind of get y'all some fresh stuff. All right, so here we go. We've got a polynomial here, and what we're going to do is see if what we can do knowing that x minus 4 is a factor. We actually want to identify all the other zeros. All right, so what we're going to do is take this factor and do a little synthetic division with it. All right, so if we're doing synthetic division, we need to use 4, because when you're given factor, you need to change the sign, right? Okay, so we've got our coefficients 1, 2, negative 31. Whoops, hit a little weird button there. Negative 31, try that again, and 28. We're going to do some synthetic division here. So we always bring down the first coefficient. Then we multiply 4 times 1 and get 4. Then we're going to add, get 6. 6 times 4 is 24. Add, we get negative 7. And negative 7 times 4 is negative 28. And I really like to see that remainder of 0. Why is that? Well, that means x minus 4 is a factor. And if I tell you it's one, I really hope it works out. All right, so what we're going to do is write our answer as x squared. Remember, one less exponent than we started with in our polynomial, plus 6x minus 7. And if we can, we want to factor this and then figure out what the zeros are going to be. Okay, so this is an old factoring question. What are the factors of 7 that add to give you 6? 7 and 1. We need a positive on the 7 and negative on the 1. Now, the directions say find the remaining zeros. I currently know all 3 factors. So how can we translate those into zeros? Well, we did that with this one when we did synthetic division. So the 0 for that factor is 4. The 0 for this first one down here, we've got x plus 7 is negative 7. And the last one is 1. So how do you get zeros if you know factors? You just set those factors equal to 0, and then you solve for x. All right, so that's how you get those. But this right here is the answer we need. All right, that's how you do it if you're given one of the factors. So let's go to the next problem. We're actually given a 0. All right, let's change colors too. So here we are. We've got a 0 of 2. Now, if I know this is a 0, I already know that's one of the answers that I need. Okay, I want to know what the other zeros are. And how we did it in the last example was we did synthetic division, and we want to do the exact same thing. But if I give you a 0, do you need to change the sign to do synthetic division? Well, let's go back up here. When we were given a factor, yes. If you're given a 0, the answer is no. So if you're given a 0, no, don't have to change the sign. All right, so get those coefficients. Okay, I'm going to do a little synthetic division. Now, when we do this, what should happen? We should get a remainder of 0. Why is that? Because a remainder of 0 means that this number is a 0, and it looks like Miss Brown has a problem here, doesn't it? I think I may have gotten a bad number. All right, hang on just a second. Let's make this a negative 2. I think I may have gotten the wrong sign. Let me adjust this here. All right. Sometimes it just doesn't work out right. Okay, hang on. Yeah, I was trying to take an old example and change it, and I think I kind of messed up just a tad. All right, so I think it originally was supposed to be a negative 2. All right, so I just had the wrong 0 listed. I apologize. All right, so let's try this again. I hope this works. If not, Miss Brown's going to have to go back to the drawing board and get another problem. Hey, there it is. Okay, so I had the wrong problem originally. I apologize about that. Okay, so anyway, now that we've gotten all that fixed, let's rewrite what we have left over and factor that. Now, that's the only way we're going to know what those zeros are is if we factor. So the factors are 20. The add to give you -9 would be -5 and -4. When you multiply them, you still get positive 20, so that's good. All right, so the 0 from your x minus 5 factor would be 5. The 0 from your x minus 4 factor would be 4. Right, so there you go. There you have it. There's your zeros for that one. Now, what we can do on this next problem is we can actually reconstruct the polynomial given the zeros. So that's what we want to do. And I have no idea why. I'm just having a bunch of stuff show up over here. All right. I'm trying to use this little cool little pen I have that I can write on the screen, but it's on a little tablet over here hooked into the computer, and it takes some practice getting used to it. All right. So anyway, what we want to do is rewrite this using the zeros. Okay, so if a 0 is 2, what is that as a factor? Oh, goodness. All right, so if you're given 2 is a 0, what does that translate to as a factor? X minus 2. All right, and 4 as a factor would be x minus 4. And -3 as a factor would be x plus 3. All right, so it's totally the opposite of what we did on the other one. All right, so what we need to do is multiply these back together. And you can only do 2 at a time. You cannot do all 3 at once. Oh, goodness. All right, here we go. So we're going to do the first 2. All right, so here we go. X minus 2, x minus 4. Now, did you have to pick the first 2 problems? Or excuse me, the first 2 factors? Absolutely not. You can pick whichever ones you want. You can only do 2 at a time, though. All right, so I'm just doing a little algebra 1 here. Multiplying these things together. Add these middle terms. All right, so we got that. Okay, good. That's only the first half, though, right? Now we have to multiply that by this. Now, here's where I would probably get out a grid. Y'all know me. I like the grid when I have these polynomials that get a little bit bigger. All right, so x squared minus 6x plus 8. Here we go. So x squared times x is x to the third. X squared times 3 is 3x squared. Negative 6x times x is negative 6x squared. Negative 6x times 3 is negative 18x. We're almost there. 8 times x is a positive 8x. And lastly, 24, we do 8 times 3. All right, so here's what we got to do. We got to gather up like terms. I see x to the third. Then I see these two. I see these two. And remember, those things are usually on the diagonals most of the time. I think there have been a few people who have figured out when that doesn't happen, and it kind of takes you by surprise, but no, most of the time it does. All right, so here we go. Negative 6x squared and a 3x squared. That's a negative 3x squared. A negative 18 and a positive 8, that makes a negative 10x. And then that 24 will just be all by itself, just your constant. Okay, so there's your answer for that one. So see how we went backwards. We went from zeros to the polynomial. And then on the first 2, we went from polynomial to the zeros. Now, eventually what we're going to do is do these first 2 problems without any kind of prompts. And so that's where this rational root test thing comes in. Okay, it's called the rational root test. Remember, roots is another word for what? Zeros, right? So how do you start with these problems if Ms. Brown does not give you one of the factors? That's really the question. You know, how does this all go down? All right, so we had a little conversation about the kind of burgers that you find at McDonald's, quarter pounders, right? So what I want you to do is remember that it goes in that order on your polynomial. Q comes first, P is at the end. And if you can remember Q and then P, it helps. All right, P and Q are the letters assigned to certain parts of this polynomial that help us figure out what it is we're trying to look for the factors of. So P is on the top of this fraction, and P is your constant. So I definitely would write this down or get those notes out from last semester for this part if you need, and you can add to it. So the factors of the constant, remember the constant is just the number at the end. Then the beginning is where your Q is located, and that is the factors of the leading coefficient. Remember the leading coefficient is that term that has the highest degree, and then you look for that coefficient on that term. So in this example 4 that we're looking at, P is 12 and Q is 1. So what we're going to do, we're not going to solve this problem. We're just going to generate a list of possible zeros if we were actually trying to find what it was. All right, so P, what are your factors of 12? Now here's my word of advice on this. I kind of start with 1 and work my way up. I know 1 goes into it. I know 2 goes into 12. I also know 3 does, and 4, and 6, and 12. All right, so there's a bunch of numbers for that. Now on the bottom, factors of the leading coefficient, 1, just a 1. All right, so here's the deal. We write this fraction because this is the rational root test. Rational implies fractions. It implies numbers that can be written as fractions. And 1 can be written as a fraction. What is it? 1 over 1. 2, same thing. 2 over 1. 3 over 1. Okay, so all of these numbers, you have to consider them as ratios. Now, if I write all of these numbers as ratios, aka fractions, with a 1 on the denominator, are they going to change from what they are presently on the top of that fraction? No, they're not, right? So when your leading coefficient is 1, it's really just the factors of the constant that you need to worry about. That's it. Did you see how that happened? All right, because we're about to do one that's not going to work out like that. Okay, and this will be the last example. I know I've got other things written here, but we're going to save that for another video. All right, so remember, let's say this is QP. All right, and when I make my list, I start with the factors of P on the top of the fraction. I go to the constant first. All right, so what are the factors of 9? 1, 3, and 9, right? What about 3? 1 and 3. All right, so I did the factors of the constant on the top, factors of the leading coefficient on the bottom. Now here we're going to have some things happen that did not happen on the other problem, because we've got 2 numbers on the bottom as potential factors of the leading coefficient, or they are factors. So we've got to think about what would happen if each one of these constant factors were written over this leading coefficient factor. Okay, so what I usually do is I will take each one of them and consider them if they were all written over 1. Well, that means 1, 3, and 9 will be factors, okay? And that's if they were all written over 1. 1 over 1, 3 over 1, and 9 over 1. Okay, now I got to go back and do the same thing, but I have to think about all of them written over 3. So if we do that, we'd get a 1/3. We would have a 3 over 3 and a 9 over 3. Okay, but I want you to look at your list, because 1, 3, and 9 are good, 1/3, but 3 over 3, what is that the same as? 1. So technically, y'all, we can omit that because it's already listed. Yes, it overlaps, and that's okay. What about 9 over 3? That's the same thing as 3. So if it overlaps, you don't have to list it twice, and you can just omit that. And what you could do is just what I did, just generate your list, write all of those things down, and then just go back and look at them and figure out which ones you don't need. And that works. All right.